Oh wait. So graphing linear inequalities is very similar to graphing linear equations. And just as a little bit of a review, you don't have to write this stuff down, but I do want to go over from section 7.1 some things that we talked about. One of the questions that's going to be asked on a quiz or a test is, what is standard form? So when we talk about standard form of an equation, what does that mean? This is from 7.1. No, what is standard form of an equation? Say it again, Sammy. AX plus BY equals C. Okay, that's standard form. And keep in mind, we're dealing with two linear variables, so we are going to have an X and a Y here. When we solve our equations in this format, we don't just have one X and one Y value. We could have a number of X and Y values. And we usually, put them in an ordered pair. We may have 2 or 3 or 4. But technically, your linear graph will go on forever and ever and ever. And so we'd have infinite numbers of these ordered pairs. The other thing we covered in 7.1 was how to graph an equation in standard form. And we looked at the X and the Y intercepts. Okay. How do we find the X and Y intercepts? What do we do? It's kind of a review that you're going to be using in this section 7.2. How do we find the X and Y intercept of an equation in standard form? Kind of, yeah. So to find the X and the Y intercepts, we plug in Y for 0, and we plug in X for 0. We do 2 separate equations, right? So when we plug 0 in for X, that'll get us the Y intercept. Our value will be 0 and then some value Y, depending on your equation. To find the X intercept, we plug 0 in for Y, and our coordinate pair will be X, 0. And so we have these 2 points that we can plot on our coordinate plane. Okay, and then we connect the lines with a straight edge, and then you got essentially your graph. Okay, so keep in mind these skills that we learned in 7.1, which hopefully by now you've gotten done with that first portion of homework. I mean, it's been over a week since we've gone over this. But you're going to use this same concept in this new section 7.2 when graphing inequalities. Okay, so this was all from 7.1. Now, 7.2, okay, like we said, it's very similar to graphing equations. We have not discussed slope-intercept form. Now, if you had Algebra 1 last year, you may know what slope-intercept form, or even in pre-algebra, you may know. But at this point in this textbook, we have not covered slope-intercept form. So all inequalities from section 7.2, we're going to be referring to standard form. So your homework, your quizzes, your tests from section 7.2 material are going to be graded according to working in standard form. Now, inequalities, okay, you can still have standard form for the inequality, except you have different versions of your inequality sign. That's the only thing that really changes. But the format where A and Y are on the same side, sorry, X and Y, and these A represent numbers, coefficients in front, that's the goal, is we want to get our equation or inequality into that form if it's not already. Now, to solve for the X and Y intercepts, I want you to make a little note. You're going to graph the inequality as an equation. Okay, and actually in our work, we're going to change the inequality sign and treat it as if it were equation. We're not changing the actual inequality, but when we do our work, we're going to treat it just like an equation. And then to do your X and Y intercepts, plug X in to get the Y value. So that's one type of work. Plug Y equals 0 into the inequality and solve. And then you'll have 2 points. These are called your X and Y intercepts. So nothing's really changed from section 7.2 from 7.1. So we're doing the exact same thing. So X and Y intercepts. Now, this is just a basic overview of what we're about to do. Let's pull out our our little green sheet that I passed out, the little foldable. I'm going to do mine on white because it shows up better on the camera, but yours should be the green. And we're going to fill out this little foldable. This is going to be on page 12 in your interactive notebook if you are at the same point with me. Okay. Now, this is just going to go through the steps that we're going to follow on each of these inequality examples. And we'll walk through several examples. You'll have a chance to do a couple on your own. But some of the wording is quite long, so if you write big, you may want to wait until I get done writing for the line. You can see how much space is actually needed, so you can do this appropriately. So, step 1 when graphing linear inequalities. And let me know if this is too bright, too dark. Is that good? Can we see that one? Okay. So step 1, your equation must be in standard form. And so I'm just going to put must be in ax plus by, and I'm going to use the greater than c format. But keep in mind, the inequality sign can be less than, greater than, or equal to, less than, or equal to. It doesn't have to just be the greater than. So you have all 4 of those versions, but it must be in standard form. Okay, if it's not in standard form, get it to standard form. Okay. Then step 2, you're going to graph the inequality. Oh, I spelled it wrong. As an equation. As an equation. I can't talk and write at the same time. And what we're doing there is we're finding the x and the y intercepts. Okay? X and y intercepts. So you're going to get 2 sets of points that you can plot and then, you know, connect your dots, if you will say. Now, step 3 and step 4 are the new parts. Okay? Step 1 and step 2, we did the same thing in section 7.1. Step 3, you need to decide if your line that connects the x and the y intercept is dashed or solid. And we'll talk a little bit lower on the little foldable how to determine whether I have a dashed or solid line. Okay. Last one, and this is the most important right here, because there's no way to look at this format and decide whether we're going to shade above the line or below. So you're going to have to pick a test point, and 0, 0 is going to be the easiest unless your graph already goes through 0, 0, and we'll talk about those exceptions later on. But pick a test point and shade. And we'll do an example here in a minute. You can see what that looks like. The little dots, I just put on here, remember your Hoy and Bucks foldable that we created to help you determine whenever you have an inequality that's set against a number, whether it's going to be a horizontal or vertical line. And we'll do some examples in our notes with that too. Okay. And make sure you get these steps down. Okay, so let's look at number 3. It says decide if your line is dashed or solid. So how do we determine this? Well, we've got to look at our inequality sign. If your inequality sign is inclusive, meaning greater than or equal to, less than or equal to, and even equations will have solid lines. When you are connecting your intercepts, if those 3 signs are in your equation or inequality, your line will be solid. Okay? Dashed lines are for those non-inclusive inequalities, so greater than or less than. And what I did on the last class is I put number 3 out here to remind you that at step 3, this is what will determine whether you have a solid or dashed line. Okay. Step 4, like I said, was the most crucial because this is going to be determined where you shade is found down here at the bottom. So these two boxes down at the bottom will describe how to do step 4. If your test point that you pick, now like I said earlier, we're going to try to pick 0, 0 unless our graph already goes through it. If your test point satisfies the inequality, meaning it makes the inequality true, you will shade the area that includes the test point. And once we do an example, this will kind of make a little more sense. If the test point does not satisfy the inequality, meaning it makes the inequality not true, you will shade the other area. Okay? So keep these in mind. We're going to go through these as we work this example, step by step, and then we're going to do several examples in our notes packet. Okay, so example, we're going to graph this inequality. First step, equation must be in standard form. Is this in standard form? Yes. Now, granted, standard form has a plus and this is a minus. Don't look at that. Just make sure that your x and y are on the same side. Okay? So, step 2, it says graph the inequality as an equation to find the x and y intercepts. So, in 7-1, we did 2 separate parts. The first one we said x is 0. The second part we said y is 0. What you're going to do on the work portion to make this easier, because if you keep it as an inequality, some of you will get confused about flipping the sign. You don't need to worry about that right now. You just need to be able to get your x and y intercepts. What I'm going to do is I'm going to change this inequality to an equation and solve just like I solved the equations in 7-1. Okay? So, plug on this first one, you're going to plug 0 in for x. So 2 times 0 minus 3y equals 12. What happens to the 2 times 0? It cancels out, right? Okay, so I'm left with negative 3y equals 12. I get y equals negative 4. And so what I can do with these two values, x is 0 and y is negative 4, is I can create an ordered pair. So this is going to be my y-intercept. Does that make sense? So this is the first task. We're going to find the y-intercept, and we're going to do the same thing and find the x-intercept by plugging in 0 for y. So 2x minus 3 times 0 equals 12. The cool thing about this is what happens to my negative 3 times 0. Just cancels out. I'm left with 2x equals 12. Divide by 2. X equals 6. So now I have these two values that I can create another ordered pair, 6, 0. This is my x-intercept. Okay, so this is step 2, finding your x and y intercepts. Now, what do you think we do with these points? We go down here and plot them. Very good. So, on your graph, we're going to plot 0, negative 4. Let me zoom out a little bit. 0, negative 4. This is my y-intercept. So I'm going to go to my 0 on my x-axis, and then I'm going to go down to negative 4. I'm going to draw a dot. Okay. My x-intercept is 6, 0. So I'm going to go to my x-axis. I'm going to go over to 6. And so now I have 2 points, and I can already see which direction my line is going to be drawn. Now, before you draw your line, step 3, you need to decide if it's going to be solid or shaded. So, we need to look at our inequality sign here. This is a non-inclusive, so this is going to be what? It's going to be dashed. Very good. So, take your straight edge. Okay, and I have a ruler, but you can do the side of the paper. And when you draw and connect your x and y intercepts, you're going to draw a dashed line. Okay, you can clearly see it's dashed, so I'm trying to work between you and the camera. There we go. Better? Now, this we're not over with. So, this is up to step 3. Now, step 4 is the most crucial. because in inequalities, we have to shade either above the line to represent what the inequality is saying, or we're going to shade below. But how we determine that is from step 4. So I'm going to do this in another color so that you can see this. We're going to pick a test point. And the most common test point, if your line does not go through the origin, will be 0, 0. It's going to be the easiest, and it's right here. We want to see if this 0, 0 is or satisfies our inequality. So 2x minus 3y is less than 12 is my inequality. What we're going to do is plug these x and y values into this statement. So 2 times 0 minus 3 times 0 is less than 12. And we're going to simplify this expression. Okay, what does this entire left side become? 2 times 0 minus 3 times 0. 0. And then less than 12. And so I need to ask myself, is this a true statement? Yes, it is. And if it's a true statement, and I want you to make note, that means that it satisfies the inequality. Well, let's go back over to our little foldable, okay, and read the 2 boxes. If the test point satisfies the inequality, which in this case it does, you will shade the area that includes the test point. So this is where you're going to take your highlighter, and you're going to shade from your dashed line the area that includes the test area, or the test point. And that is your graph of an inequality. Okay, and so what this represents is that everything that's shaded would satisfy the inequality drawn above, or that was written out above.